planet is covered by a vast ocean of air. This layer of gases supports all life on Earth. It holds clouds of water vapour that drop life-giving rain, and it's a blanket that retains warmth from the sun. But human activity is increasing the level of carbon dioxide in the atmosphere, and it is holding more heat, leading to unwanted changes to familiar weather patterns. The atmosphere is really a very fine layer covering the Earth. In proportion, the skin of an onion is thicker. Thermal variations in the atmosphere drive the winds that keep the air and clouds circulating, leading to variable weather. Over the past decade, new records in storm severity have been recorded, only to be exceeded a year or so later. More than 40,000 thunderstorms occur around the world each day. In the United States, where accurate weather records have been kept for around 200 years, experts have noted an increase in the frequency as well as the severity of storms. This is consistent with scientific projections of how weather patterns will change as the atmosphere warms. The increase in temperature means clouds hold more moisture that leads to heavier downfalls and increased risk of flooding. Hurricane Katrina, that devastated New Orleans in 2005, was one of the 5 deadliest hurricanes in the history of the United States and was the 3rd strongest hurricane on record to make landfall there. Meteorologists are desperately trying to understand how changes to the climate will unfold. The EUMETSAT headquarters coordinates information from a new satellite system designed to track global climate change. The weather satellites, constructed and tested at Darmstadt in Germany, deliver greater details on weather changes, as well as trace gases and moisture profiles within the atmosphere. The satellites monitor the world to give weather organisations more information and also act as an early warning system when extreme weather patterns are developing. Since its launch in 2006, Meteosat-8 has been providing atmospheric data, along with sea surface temperatures and sea ice concentrations. It can accurately measure temperatures at different levels in the atmosphere and represents a breakthrough in the global monitoring of the climate. The lack of observational coverage in the Pacific Ocean and continents of the Southern Hemisphere has led to the increasingly important role for polar orbiting satellites, able to overfly every part of the Earth. These polar orbiting satellites are able to observe the atmospheric system with microwave sensors that provide improved coverage of the stratosphere. Microwaves penetrate clouds that block visible and infrared observations, and they can probe the interior of clouds. Another satellite is monitoring wind direction. It uses a laser system to measure currents in the atmosphere. It will provide accurate wind profiles for the entire planet, including remote areas lacking any ground-based weather station. Updrafts in storm cells generate huge amounts of static electricity we know as lightning. About 10% of storms feature an overabundance of moisture in the lower atmosphere, which feeds an updraft with such vigour that it becomes greatly magnified and begins to rotate. In the most extreme cases, these can become tornadoes. These supercell storms can maintain an intense, steady state for many hours and actually exert control over the surrounding environment rather than being affected by it. The frequency of such extreme weather events is not only increasing, but tornadoes are occurring over a broader range. What were regarded as freak conditions are part of a new normality, and scientists are filling the skies with more complex monitoring satellites to help deliver more accurate weather forecasts. Current satellite technology relays images of the Earth every half hour. MSG-1 will double that speed and relay back higher resolution pictures and 20 times more data for a more accurate weather service. The new satellite gauges information on moisture, cloud buildup, and ozone concentrations. When combined with data sets from ground stations across the globe, it will help predict the onset of extreme conditions. Other potential users of the new space observations delivered by this satellite include civil security services, who will be able to gauge the extent of natural disasters and coordinate rescue operations after flood or fire. Over the next 10 years, 2 more satellites will be launched, allowing meteorologists to observe changing weather patterns quicker and more accurately.